So far this unit, we've talked about the electromagnetic spectrum and about refraction in lenses, and we touched on reflection during a previous unit. Let's get down to the important facts about reflection as it relates to mirrors. Just like for refraction, for reflection we're going to measure our angles from the normal, or the line perpendicular to the surface. The law of reflection states that the angle of incidence, theta I, is equal to the angle of reflection, theta r. Remember that incidence means starting ray, and the reflected ray is the one that's leaving the surface. So in equation form, theta I equals theta r. There's no calculation needed because the angles are equal. There are two types of reflection I want you to be familiar with. The first is the type that gives a clear reflection. This is called plane reflection. A smooth surface, where all waves have the same angle of incidence, will give a clear reflection, since all waves have the same angle of reflection. Since the angles are the same, parallel rays going in are still parallel coming out, and you see an accurate representation of the object. If the surface is not smooth all the way to the microscopic level, you'll get a distorted image. This is called diffuse reflection. Most surfaces will give you diffuse reflection. You may not get any image at all. My lab counters and tables reflect some light, and sometimes you'll be able to see a shadowy reflection of your face on the table, but it's not a clear image like from your bathroom mirror. This is diffuse reflection. Diffuse reflection happens because each ray of light has a different angle of incidence, and therefore has a different angle of reflection. So rays that are parallel going in are no longer parallel going out. So to recap, plane reflection gives a clear image, while diffuse reflection gives a distorted image. Plane mirrors give plane reflection. When we say plane, we mean a flat plane, like in math class. All images given by a plane mirror will be virtual, since they can't be projected onto a screen. As you found with lenses, all virtual images are also upright, which is good since trying to fix your hair in front of a mirror which flipped your image over would be difficult. Plane mirrors show images that appear to be the same distance from the mirror as the object, and they appear to be the same size as the object. You will not be drawing any formal ray diagrams with plane mirrors since they don't have a focal point to focus the light rays. Be aware though that you will have virtual, upright, same size, and same distance images for all plane mirrors. The two mirror types you will be working with are concave and convex mirrors. Both of these mirrors have a single focal point and curve in a specific way. This CAT macro shows the basics of convex and concave. Let's look at this more closely. For concave, the center of the mirror is curved away from the object. Remember that objects are typically arrows. The reflective part of the mirror is going to be on the inside of the curve. For convex, the center of the mirror is curved toward the object, so the reflective part of the mirror is on the outside of the curve. To recap then, a concave mirror has the center pushing away from the object, and a convex mirror has the center pushing toward the object. We'll get to ray diagrams for these curved mirrors in the next video.